Hello there, Michael Holohan here. Well, is this a secret? It's the diesel engine soot reducer. Is it actually a secret? No. It could really be called an overlooked concept for industry. And the point of this intellectual property is it's a closed loop control for reducing soot in diesel, gas, and alternative fuel engines. And we accomplish this by electronically controlling the flow of oil through oil jets to the piston undersides. And that will reduce soot in the crankcase as well as out the exhaust. Now let's look at why we pursued patents in this area. All right then, tell me why this is necessary. All right, here's why. I like to call it the burning platform, if I may borrow a Six Sigma term, is to somehow reduce the quantity of oil at specific loads that is available for cooling and lubricating the pistons and liners. Oftentimes there's too much oil washing around there and it ends up in the combustion chamber or down or washed down into the sump. And the background for this is due to the fact that many manufacturers they design for maximum oil flow cooling to the pistons, actually for worst case operating condition. It results in piston temperature decrease to below its critical operating temperature, generally at light loads. This creates poor combustion. So what happens then is this non-optimal operating temperature creates a lower piston dome surface temperature, sometimes referred to as supercooling. So at these light loads, this poor combustion results in soot particles washing down to the oil sump and out the exhaust. Actually, some diesel engines and gas engines, they have spray nozzles or oil flow nozzles, which directs crankcase oil to the piston undersides for the purpose of maintaining a safe operating temperature for the piston. So we use those flow nozzles such where we modulate a solenoid valve which delivers cooling oil to the piston underside. A software table lookup is incorporated to dictate the optimal pulse width to allow improved combustion. Hence, reduce soot in the crankcase and output exhaust. Does industry know about this concept? Well, in answer to that, yes. In 2022, we received an honorable mention in Create the Future by the SAE Media. It was a contest, a global contest, and we placed within the top 100 entries. Let me explain how this works. Our soot reducer is broken down into a handful of automotive components and can be explained as follows. Oil is drawn from the oil sump, number 14, through the pump, number 16, then to the inlet of solenoid valve 12, whereas it exits solenoid valve 12 and enters the oil flow jet, number 20, with a spray pattern shown as number 22. This oil flow is directed to the piston dome underside for cooling and lubrication. You'll also notice item 28, which is our electronic engine control. That's responsible for the PWM control based on software table lookups for controlling item 12. Okay, let me get into a little more detail on this. This illustration satisfies the aforementioned needs with a patented piston dome cooling system 10, comprised in one aspect of a pulse width modulated solenoid, number 12, wherein lubrication oil from the oil pump, number 14, is pumped by the oil pump 16 through a common rail manifold number 18 through valve 12 to spray nozzle 20. One spray nozzle is generally utilized per cylinder, and oil spray quantity 22 is illustrated in this embodiment with a reduced modulated quantity of spray, preferably directed below the piston dome number 24. The motivation for this invention is to base the amount of oil used in cooling and lubrication to the amount of thermal loading imposed on the piston due to increased loading, and perform it in a closed-loop fashion. The amount of oil delivered to the spray nozzle, number 20, shall be a function of engine feedback parameters, read by sensor block number 26, of engine controller number 28, and a resultant pulse width command signal number 30, based on lookup tables number 32. In particular, the pulse width duty cycle signal shall modulate the valve number 12 anywhere in the range of 0 to 100%, wherein 0% represents a shutoff valve, no oil flow, and 100% is fully open, which reflects max power. Now, I read you this as I would draft a patent because to me it's the most clear way to explain how something works. Okay. All right, here's the actual detailed description that I just read you. So if you need to go back and refer to this, it'll be here. All right, has this soot reducer actually been developed? Well, in answer to that question, yes, to a point. An initial proof of concept oil flow jet control was tested in a highly regarded Ann Arbor, Michigan automotive diesel research facility. And this was under an EPA SBIR Phase 1 government grant. The title of this, Diesel Engine Efficiency and Emission Control Improvement via Piston Temperature Control. You can see the laboratory there. There's a test cell with the test engine used was a Dodge Cummins 5.9 liter inline 6 diesel modified for single cylinder operation. So basically we performed the research on just one cylinder. And then you can see the observed benefits of the piston temperature control. It's basically the exhaust particulates are way reduced, as well as the hydrocarbon emissions, and also there's quite a quicker, faster warm-up at idle, which also will reduce emissions. So this just was an initial proof of concept test that had some successful results. So I hope you enjoyed this video, and stay tuned for another one.